The room is warm. Nothing around you has changed in the last 30 seconds. And yet, right before you're about to speak, in an interview, on a call, in front of a room, you notice it. Your hands have gone cold. Not slightly cool, distinctly, unmistakably cold, like you'd just come in from outside. Nothing in the room explains it. The temperature hasn't dropped. You haven't moved. The only thing that's changed is what's happening in your mind. Here's what makes this stranger than it first appears. This reaction is fast, specific, and precise enough that real devices, actual pieces of technology used in clinics and more recently in consumer wearables, are built around measuring exactly this signal to track how stressed a person is in real time. Your hands, in a very literal sense, are functioning as a built-in stress gauge. We'll get to how precise that gauge actually is. First, we need to follow the plumbing, because the reason your hands specifically go cold, rather than your arms or your chest, is not an accident. It starts somewhere you'd expect. A perceived threat, real or not, reaches a part of your brain responsible for detecting danger, and within a fraction of a second, a cascade begins. Your hypothalamus signals your sympathetic nervous system, and your adrenal glands release a pair of chemical messengers into your bloodstream, noradrenaline and epinephrine, more commonly known as adrenaline. Piece 1. This isn't a slow hormonal shift working over minutes. It's one of the fastest whole-body signals your nervous system is capable of sending. Those chemical messengers travel through your blood and reach receptors on the walls of blood vessels all over your body. But not all vessels respond the same way. On the smooth muscle lining the small blood vessels of your skin specifically, they bind to what are called alpha-adrenergic receptors, and when they do, those muscles contract. Piece 2. The vessel narrows. Blood flow to that patch of skin drops. This is vasoconstriction, and it's the same basic mechanism your body uses to conserve heat in cold weather, borrowed here for an entirely different purpose. But this still doesn't explain why fingers, specifically, more than almost anywhere else on your body, feel the effect first and most intensely. For that, we need to look at something most people have never heard of, hiding just under the skin of your palms and fingertips. Scattered through the glabrous skin of your fingers, palms, and the fleshy base of your thumb, skin without hair, technically distinct from the skin on the back of your hand, are structures called arteriovenous anastomoses, direct shunts connecting small arteries straight to small veins, bypassing the usual capillary network almost entirely. Piece 3. These structures exist in far greater density in your fingertips and palms than almost anywhere else in your body, and they are extremely richly supplied with the same sympathetic nerves we just described. When those nerves fire, these shunts close first and close hardest. Researchers have actually tested this directly, not just with cold exposure, which is the more obvious trigger, but with psychological stress alone. In one study, researchers measured blood flow in finger and palm skin, the areas rich in these shunts, compared to skin on the back of the hand, which lacks them, while subjects underwent a forced mental arithmetic task designed purely to induce stress, with no change in temperature at all. Blood flow dropped sharply in the shunt-rich skin. It barely changed in the skin without them. Which means the specific, disproportionate coldness you feel in your fingers under stress isn't a diffuse, whole-body chill. It's a targeted, anatomically specific closing of a particular kind of vessel that happens to be concentrated almost exactly where you feel it most. Piece 1, 2, and 3 together. A fast chemical signal, a receptor that constricts vessels, and a dense cluster of highly reactive shunts concentrated in your hands. But there's still a why we haven't touched. Why the body would bother routing blood away from your hands specifically, at exactly the moment it seems like you'd need them. The likely explanation connects back to what this entire response evolved to prepare you for. In a genuine physical emergency, the kind your sympathetic nervous system was originally built to handle, blood flow gets prioritized toward large muscles, the heart and the lungs, the tissues doing the actual work of fighting or running. Skin, and particularly the skin of the extremities, is comparatively low priority in that moment. There's also a secondary, commonly cited possibility. Reducing blood flow to the skin's surface, including the hands, may have offered some protection against blood loss in the event of an injury during a physical confrontation. Less blood readily available at the surface where a cut or scrape would be most likely to occur. This part is a reasonable, evidence-consistent hypothesis, rather than a fully settled fact, but it fits the pattern of a system built for physical danger, running now in response to a purely mental one. And this is where the story becomes genuinely strange, because the threat in front of you, an interview, a difficult conversation, a room full of people, isn't a physical one at all. There's no injury risk, no muscles about to sprint or fight, and yet the exact same ancient circuitry fires anyway, rerouting blood away from your hands to prepare for a fight that was never going to happen. Which brings us back to the gauge we mentioned at the start. Because your hands respond this precisely, this quickly to stress, and largely independent of ambient temperature, researchers realized decades ago that skin temperature at the fingertips could be used as a measurable proxy for how activated a person's stress response actually is. This isn't a new idea dressed up for this video. Skin temperature biofeedback, developed and studied since the 1970s, trains people to consciously warm their own hands, a skill that, when it works, reliably correlates with a calmer, less sympathetically activated nervous system underneath it. More recently, the same underlying signal has shown up in consumer technology, wearable rings and bands that track finger or wrist temperature, specifically because a sudden drop is one of the more reliable, fast-responding markers of acute stress available from the surface of the body, without needing a blood draw or a lab. Piece 4. The reveal. The cold hands you felt 100 times before an interview or a hard conversation aren't just a subjective, vague sensation. They're a real, physiologically precise, measurable signal, accurate enough that entire pieces of technology exist purely to read it. None of this means cold hands always indicate significant stress, or that warm hands mean the opposite. Many other things influence hand temperature, including ambient temperature, circulation differences between individuals, and certain medical conditions unrelated to stress, some of which are worth discussing with a doctor if the coldness is severe, persistent, or accompanied by pain or color changes, rather than a brief response to a stressful moment. But for the ordinary, situational version, the specific, fast chill that arrives right before you speak, right when the pressure spikes, and fades again once the moment passes, the evidence points clearly toward exactly the mechanism we just walked through. So the next time it happens, right before you walk into a room, right as the call connects, right as your name gets called, you'll know what's actually happening underneath your skin. A signal moving through your bloodstream at the speed of a chemical messenger. A cluster of specialized vessels in your fingertips, closing, almost on cue. And an ancient system, built for a kind of danger you will almost certainly never face, quietly preparing your body for a fight that was never going to happen. Somewhere, right now, someone is about to walk into a room, and their hands are already cold before they've said a single word. They'll probably call it nerves, and leave it there. It's actually something far more specific. A 200,000-year-old alarm system, still routing blood away from their fingertips, still preparing them for a fight that stopped making sense a very long time ago.